In this video, we're going to do a bunch of different circle constructions. The first one that we're going to do is we're just going to construct a circle given segment AB as the radius. In order to do that, we're just going to put our compass on one endpoint of the line segment and we're going to open up as accurately as possible to the other endpoint. And on the computer, it's a little bit hard to be 100% accurate, so I'm going to get as close as I can. And then I'm going to just spin a circle around and notice how AB is the radius of this circle. Let me see if I can make mine a tiny bit more accurate. Let me try to line this up a bit better. Once again, this is a little bit difficult to do on the computer. Okay, that should be more accurate. There we go. And that's a circle with radius AB. The diameter would be twice AB. The next construction that we're going to do is we're going to determine the center of the circle. I would love to just dot a dot in the middle and say this is the center, but I can't do that. I have to use constructions to make sure that I for sure know where the center of the circle is. So what I'm going to do is I'm going to start with any two chords. And if you're trying this on paper, you can just draw any two chords in your circle with a straight edge, of course. An ID card, a ruler, any form of straight edge. And what we're going to do is we're going to take each of these chords, and once again, it doesn't matter which way the chords are facing, I just drew mine like this, but we're going to take the perpendicular bisector of each chord. So first, I'll do the perpendicular bisector of the chord on the left. And I'm going to open up to more than halfway down. The exact distance doesn't matter. Arc above, arc below, and then I'm going to go over to the other endpoint of that chord. And I'm going to do the same arc with the same distance. And from here, all I'm going to do is draw a line with my straight edge through the intersection. And that's my perpendicular bisector. That yellow line is my perpendicular bisector of this chord. I'm just going to repeat the process, and I'm going to make the same exact perpendicular bisector for the other chord. I'll use a different color so we can see the difference in the arcs. Otherwise, it can start to appear messy. Okay, I'm going to go into one endpoint, and any distance, it doesn't matter, just more than halfway down, arc above and below. I'm going to go over to the other endpoint, and using the same distance, here we have the same arc. And using my straight edge from one intersection point to the other, I'm just going to draw my perpendicular bisector. So the center of the circle is where my two yellow perpendicular bisectors meet. And let me get a different color to dot the center. So here's one yellow one, here's the other yellow one, and they meet right over here at this point, which is the center of the circle, and it does appear to be in the center of the circle. Moving on to the next circle construction that we're going to do in this video, we are going to construct the tangent to circle O to the circle at point C. So a tangent is just a line that intersects the circle in one spot. So just with a straight edge, not with constructions yet, I'm just going to show you what we're going for. So we want a line that only, a line that only touches the circle at this point C. So this is what we're going for here. And just to refresh your memory, when we have a radius of the circle and a tangent line that intersect, they intersect to form a 90-degree angle. So we need to make sure that the radius and the tangent line that we construct are perpendicular to each other, that they create a 90-degree angle. So the construction that we're going to be doing is a perpendicular line through point C. In order to do this construction, the first thing that we're going to do is we're going to use our straight edge, and we're just going to extend line OC a little bit just to make the construction easier. The reason why we're going to use our straight edge to extend the segment a little bit is because when you're doing a perpendicular line through a point construction, The first step is that you put your compass on the point that you want your line to pass through. So we're going to put it on point C. And we need to make an arc that intersects the line in two spots. As you can see here, if I didn't extend the line at the beginning, it would have been very difficult for me to see the second intersection point. When you're doing constructions, you can always use your straight edge to extend your line slightly if it will make your construction a bit easier. Okay, so here we have our two intersection points. I'm going to put my compass on one of those intersection points first. It doesn't matter which one. I'm going to pick any distance. Once again, it doesn't matter. Any distance. I'm going to just make it slightly bigger than what I used before. And I'm just going to make an arc. Using the same distance that I just used, I'm going to go over to that other intersection point that I dotted before. And I'm going to make the same arc. Now what I'm going to do is using my straight edge through this intersection point, I'm going to make a line that also passes through point C. So I'm not very good at doing this on my computer. Definitely so much easier to use a straight edge on paper, but I got my line through the intersection point and passing through point C. And as you can see, where they intersect, we do have a 90-degree angle because a radius and a tangent line to a circle are perpendicular. They do form a 90-degree angle. What we're going to do now is we're going to make the tangent to circle O from the outside point P. And you may remember that when you have a tangent to a circle from an outside point, there's two possible tangents that exist. There's one that's somewhere over here, and there's one that intersects the circle somewhere over here. And remember, two tangents to the same circle from the same point are congruent to each other. So when we're making our construction, we want to keep all of this information in mind, and we want to make the two possible tangents to the circle, and we want to ensure that they are congruent to each other because they should both be the same. What we're going to do first, we're going to use our straight edge, and I'm just going to connect points P and O with a straight line. What I'm going to do now is I'm going to construct the perpendicular bisector of segment PO. If I could ever move my compass to the right spot. So I'm going to put my compass on point P, and then the exact distance doesn't matter, but I do want to be more than halfway down the line segment. Arc above, arc below. Having gone over to point O and doing exactly the same thing with the same distance, without changing anything, arc above and arc below. And just like the previous couple of times, right through that intersection point, we want to make our perpendicular bisector, with our straight edge. So from this point to this point, connect through, and there, that yellow line is our perpendicular bisector. So what that did is it gave us the midpoint of segment PO. What I'm going to do now is I'm going to take my compass, and I'm going to stick my compass on that midpoint. Let me turn it upside down on here so I can actually see what I'm doing. Once again, constructions are very annoying on the computer. Okay, there we go. And I'm just going to measure to point O, and I'll just put a little arc to indicate that I measured. That just shows I measured it with my compass. And using this distance, I want to make an arc that intersects the circle on top, and using the same distance, an arc that intersects the circle on the bottom. And what I'm going to do is I'm just going to use my straight edge once again, and I'll use a different color to connect. And starting at point P, with my straight edge, I'm just going to connect to that intersection point at the top of the circle. And then I'm going to connect to the intersection point at the bottom of the circle. And here we have our two tangents to the circle. They are congruent to each other. We ensured that they do have the same length due to our perpendicular bisector and measuring to ensure that the same distance from here to here applies to both of the tangents. Those are the two possible tangents to circle O from outside point P. Our next circle construction is we're going to be making a hexagon inscribed in circle O. This one's pretty straightforward. A hexagon is a six-sided figure, and we are going to be making an equilateral hexagon, so all the sides are going to be equal to each other. Okay, now I have my compass. So I'm going to start off with my compass on point O, and I'm just going to reach out until I'm on the circumference of the circle. And I just wanted to dot that point. And just to make it a little bit easier to see what I'm doing, I'll actually draw in that radius so you can see exactly what point it hit at. And I'll just dot that point a bit better right over here. It'll make it easier for me to do the construction as well, because on the computer it's so hard to see what I'm doing. What I'm going to do now is, without changing what I measured before, so using the same distance, I'm going to come on over to that point, and once again using the same distance, I'm just going to intersect the circle. And then all of this is without changing the distance. I'm going to go over to that intersection point, and I'm going to intersect the circle. And then I'm going to move on over to that point. Let me try to make it as accurate as possible. Once again, on the computer, it is very difficult to be accurate. And there should be 6 of these in total. And we're just following the same pattern. We're just going around without changing the distance. You'll be a lot faster than I am, because on the computer I have to keep retilting my compass every second. Just being super careful. Oops. Draw a compass. There we go. Just being super careful not to change the distance that my compass is open at. Those of you watching along are probably done with this construction already. And it's going to take me another year to do this on the computer. Finally, almost there. Okay, and then if I did this accurately, the last arc that I make should be on my starting point. I don't expect to be 100% accurate on this computer here. I was pretty close. But once again, if you did this accurately, this last arc should line up with your point that you started at. Once again, mine was not the most accurate because I was using the computer, but it was pretty close. Okay, so then I'm just going to connect each of those intersection points together. With my straight edge. And there we have our hexagon inscribed in the circle. The next construction that we're going to do is we're going to do an equilateral triangle inscribed in the circle. Now, I'm not going to redo the whole construction because the construction for equilateral triangle is the same for the hexagon. The only difference is how you're going to connect your points at the end. There we go. This didn't delete from before. Let me delete it because I was just resetting this one. Okay, the only difference is after you make your 6 arcs, equally spaced arcs for the hexagon construction, instead of connecting all the points together, we're just going to connect every other point together. And it doesn't matter which 3 points you connect. Your triangle will just be facing a different way on its side, face up, upside down, doesn't matter. It'll be the same triangle. So I'll just start with this point and skipping a point and skipping a point. And based on the ones I chose to connect, this is going to be like a tilted, like upside down triangle, but that's okay. It'll still be an equilateral triangle because all the sides are equal because we made equally spaced arcs. And there we go. That is our equilateral triangle. Same construction as a hexagon. Instead of connecting all the points, we're just connecting every other point together. Okay, the next construction that we're going to do is we're going to make a square inscribed in circle O. This construction is pretty simple. All we're going to do is use our straight edge to draw in a diameter. Oops, gotta actually pass through the center for it to be a diameter. Oh no, I missed again. I will get it eventually. Once again, you're probably done with this part already. Okay, there we go. I have a diameter. It doesn't matter if you make the diameter face this way or this way, it's the same thing. And then what we're going to do is we're going to use our compass to construct the perpendicular bisector of the segment. And I'll just use another color so there's not too much green going on here. Compass on one point, open up more than halfway, doesn't matter. The exact distance, just more than halfway. Arc above, arc below, keeping the same distance, moving on over to the other endpoint. Arc below, arc above, and then we're gonna get our straight edge again, and we're just gonna connect through those intersection points. And there is our perpendicular bisector of the diameter in yellow. Do you see the square? All we need to do is connect these points together, and there's our square. I'll do this in red. Oh no. There we go. And there's our square. Congruent diagonals, making it a rectangle. Also, the right angles making it a rectangle. A rhombus because it's got 4 equal sides. We got a square. If it's a rhombus and a rectangle, it is a square. Okay. The next construction is a little bit more involved. We are going to circumscribe triangle ABC, and that means that we're going to make a circle surrounding it so that all of the vertex points, all of the vertices are included in the circle. Now, in order to circumscribe the circle, we first need to find something called the circumcenter. And you may remember that the circumcenter is the triangle center that's created from perpendicular bisectors. It's the point of intersection of the perpendicular bisectors of a triangle. So what I'm going to do is I'm going to construct the perpendicular bisectors of the triangle. I got to grab my compass. It's at the top of the screen, but we want it at the bottom of the screen. It's annoying. I'm going to keep bringing that down. And I'm just going to choose 2 sides to construct the perpendicular bisector of. In order to be like 100% accurate, we should technically do the perpendicular bisector of all 3 sides, but 2 sides is enough to see an intersection point. So more than halfway, arc above, arc below, and this one's going to get messy. Over to the other endpoint without changing the distance, arc below, arc above. It's going to get messy because it's got a lot going on, a lot of different arcs. And that's our perpendicular bisector of this first side that I chose to do the perpendicular bisector of, side BC. I guess just to make it less messy, because we already got stuff going on over here, I'll just do the perpendicular bisector of side AC as well. So I'm gonna go over to one endpoint, more than halfway down, but I still want to be on the line segment. I'll just use black for this one. Arc above, arc below. Without changing the distance, I'm gonna go over to the other endpoint of that side, and I'm gonna do the exact same thing. And through those intersection points, I'm going to connect to make my perpendicular bisector. Now, the point where those red perpendicular bisectors meet is called the circumcenter. You probably remember hearing about that when you did triangle centers all the way back in semester 1 of geometry. And although we learned what it was in semester 1 and we learned how to construct it by constructing perpendicular bisectors of the sides of the triangles, we didn't really learn what it was used for. And we're going to use it now. We're going to use it as the point to circumscribe the triangle. So if I put my compass on the circumcenter, the reason why the circumcenter is so special is because if you open up to any one of the 3 vertex points, and once again, this is not going to be the most accurate because I'm on the computer here, and you just make a circle it should circumscribe the triangle. And what that means is it should hit every single vertex point in that circle. And that's what's so special about the circumcenter. It helps you circumscribe the triangle in the circle that touches all of its vertex points. As you can see here, mine wasn't 100% accurate because it went close to getting all the vertex points in it, but not completely. But we try to be as accurate as possible. We're not going to get 100% accurate, especially on the computer, but I think this was pretty accurate for doing this on the computer. And that is circumscribing the triangle with a circle around it. We're going to do the opposite, I guess, the reverse, in the next example, and this is our last circle construction. And what we're going to do is we're going to inscribe the circle, and this one is going to be the most challenging. By inscribing a circle in triangle ABC, I mean instead of making a circle that goes around the triangle, we're going to make a circle that goes inside the triangle. And we have to be really careful here because we want the circle to stay within the walls of the triangle. We want it to touch all the walls, but we want it to stay within the walls of the triangle. We don't want it to come out. So in order to inscribe a circle inside of this triangle, we're going to have to first make the incenter. And you might remember from semester 1 as well that the incenter is the special triangle center where the angle bisectors meet. So just like with the circumcenter where we had to make at least 2 perpendicular bisectors to see the intersection, we're going to make at least 2 angle bisectors here to see the intersection. Okay, I'm bisecting angle B. All I did was make an arc with my point on angle B, doesn't matter the distance. Then we're going to come up here to the first intersection point. You can use the same, you can use a different distance. It just needs to be the same on this intersection point and this intersection point, but it doesn't necessarily have to be the same distance you were using for the initial arc. Oops, computer wants to be weird now. Okay, and that's one angle bisector in red. And then we're going to construct the angle bisector of another angle. I'll just do angle A because it's out of the way from the other arcs. I don't want to make things too messy here if we don't have to. So on angle A, I'll use a different color so we can see the 2 different constructions. Let me use blue for this one. And once again, any arc, it doesn't matter, onto one intersection point. You can even use the same distance, or you can make it slightly bigger, it doesn't matter. I just want to make it as least messy as possible, so I'm just using the same distance. And then from the vertex, right through that intersection point, we have our angle bisector. So here we have it. Oh, this one looks slightly off to me. I want to fix my connecting here because I want it to be as accurate as possible. So I just completely missed the intersection point. There we go. That looks better. That looks like it's right through the intersection point now. So we see where our angle bisectors meet. And this is our incenter. But unfortunately, unlike with the circumcenter, we can't just stick our compass on there and inscribe a circle and expect it to work. Unfortunately, let me show you. So let's say I put my compass on this point, and I wish I could move my compass over. Okay, let me move my compass over. Let's say I put my compass on this point on the incenter, and let's say I opened up to A. That's not within the walls of the triangle. So as you can see, that just doesn't work. That's not inscribed. So what we actually have to do is we actually have to create a perpendicular line through the incenter. So we're going to make a perpendicular line through the incenter just to a side of the triangle. And I'll just do to side BC over here. So in order to do that, we're going to take our compass, and whenever we want to make a perpendicular line through a point, we're just going to put our compass on the point that we want our line to pass through. If my compass will allow me to grab it, there we go. So right here on that point. And then we just want to make an arc that's going to intersect that line segment in 2 spots. So I'm going to be using yellow for this arc so we can tell the difference. And notice it hits the side of the triangle in 2 spots. So now, let me just dot those intersection points real quickly. I'm going to take my compass and I'm going to go over to one of those intersection points and I'll just slightly make my distance a little bit bigger and I'll make an arc. And then using the same distance, I need to go over to the other intersection point and make the same arc. And through that intersection point, to the point that we wanted it to pass through to the in-center, we're going to use our straight edge to make a line. And I'll just use black for this line. So through that intersection, right to the in-center, that's our perpendicular line through the in-center. And notice how it makes a 90-degree angle with the side of the triangle. So it's perpendicular line to the side of the triangle that passes through the in-center. And where it hits the side of the triangle, that's a very important point. Because what we're going to do, and we're done with the construction now, by the way, we just have to finish it up. What we're going to do, why can't I take my compass? Is we're going to take the compass, and we're just going to measure from the in-center. Let me turn it around so I can better use this. To the point where it intersected the side of the triangle. Let me try to open this up as accurately as I can. Once again, on the computer, it's not going to be 100% accurate. And once I open up from the in-center to this point that we found on the side of the triangle, if I swing my compass around, we should be able to inscribe a circle inside the triangle, as you can see, such that the circle is completely inside the walls of the triangle, but touches the walls of the triangle. So that was angle bisectors to make the in-center, and then a perpendicular line through a point to find this point, open up from here to here, and swing a circle.